So on number 13, we want to identify the vertex. Problem is, this is not in vertex form, it's in standard form. And in standard form does not tell us the vertex by just looking at it. So there's got to be a way to get the vertex from standard form, and there is. And it's using this formula, negative b over 2a. Well, we've already learned that this number right here, that's what we call the a. So I will be putting an a right there. So in mine, I'll be putting a 2 in for a. And I also know the second number is what we call a b. So I will be putting that right here. And what this will tell me is the x value of the vertex. So I just need to substitute values in. And the first value I see is b. b goes on top. My b is negative 16, so I need to put a negative 16 right here. This value, if you look at it, is a. So it's negative b over 2a. So my a is 2. So I put a 2 here. From there, negative 16, that makes positive 16. 2 times 2, that's 4. And 16 divided by 4 is 4. So here's what we know so far. We know that because the 2 is positive, it looks something like this. And it's symmetrical on both sides. And we know the line that cuts this in half is x equals 4. And that's called the axis of symmetry. And even more, we know that this point right here, called the vertex, is 4 something. Now, we know the value of the vertex is going to be somewhere where x is 4. Luckily, in order to find the y value, we have an equation that says, hey, if you know any x value, just plug it in. That'll spit out the y. And so that's what I'm going to do next, is I know that to find the y, you just take 2 times your x squared minus 16 times your x, and then you add 31. And the one I'm curious about is when x equals 4. So I need to plug 4 into this equation. This is called substituting. So I'm putting 4 in. And then from here, you could just type all that in your calculator at once, but I'm going to go ahead and work it out. Order operations say to. So doing the math, I do exponents first. That's 4 squared is 16. And then 16 times 2, that's 32. (16 times 4), that's 64. And then plus 31. Now, if I take 32 plus 31, I get 63. 63 minus 64, that's negative 1. So I just found the y value of the vertex is at 4, negative 1. So that's the vertex. Now, if they wanted me to write this in vertex form, which they did not tell me I had to, vertex form says you take y equals x something squared, and what we're going to plug in there is we're going to plug the 4 in here. That's going to become a minus 4. It's always the opposite. we're going to plug in a 1 or -1 here. It's always the same. And if you were to compare those two graphs, you would see they have the same vertex, except this one is skinnier. And so the thing kids forget is this is very important for the size of your graph, the vertical dilation. So I also need to put the 2 up here. So now I have vertex form, I have the vertex, and I have standard form. Now I'm going to type all this into Desmos and compare. So the first problem was y equals 2x squared minus 16x plus 31. When I look at this, I see my vertex is 4, -1. I said the vertex is 4, -1. And then I'm just going to compare this and make sure I have the same equation. 2x minus 4 squared minus 1. Y equals 2x minus 4 squared minus 1. And notice they are the same thing. They're just different forms. If I had forgotten the 2, notice same vertex, just not skinny enough. So to make it skinny, that 2 is important. Now, y-intercept right here, if you have standard form, it says the y-intercept's 31. Look at that. If I go up here, the y-intercept is indeed 31. So standard form tells you the y-intercept, vertex form tells you the vertex, and then if I had done factored form, that would tell me the x-intercepts, assuming it does factor. So looking back, identify the vertex. This is the only part I really needed. 4